Hello class. So we'll look at a few homework questions together here. So the first question was this: how many positive integers less than 1,000 have an odd number of factors? Now, what does this odd number of factors imply? That's right. As we have discussed in class, this means we are looking at the perfect squares. You see, the perfect squares have odd number of factors. Then essentially this question simplifies into how many numbers, how many perfect squares do we have from 1 to less than 1,000. So basically what we can do is this: we can take the square root of 1,000. Yes, if you had to try to do square root of 1,000, what would you end up getting? So I'm going to just use the calculator on the side quickly. So here it goes. Square root of 1,000. As you can see, this one gets us about 31.6. That means there are 31 numbers that has odd number of factors. Alright, let's move on to second question. Let 24k be a square of an integer. Now, the fact that something has to be a square of an integer, then when you turn that into prime factorization, such as if n is a square of an integer, let us say another number, whatever the k is, then we know that it has to be first prime to the some sort of even exponent, second number to the another even exponent, and third number to the another even exponent, and so forth and so on. Then what do you realize about 24k? 24, we realize that it's 2 to the third power times 3 and k. In order for this one to resemble something like this, 3 as an exponent is not good enough. K has to have a value that is 3. K has to include 2. Then if k includes 2, then what's going to be happening is 2 times 2 to the third power becomes 2 to the fourth power. How about 3? Since 3 is 3 to the first power, that means we need another 3 to make the 3 square. So if k is equal to 2 times 3, then we get to realize 24k becomes 2 to the fourth power times 3 squared. As you can see, each exponent is an even number. That makes 24k as a square of an integer. Alright, let's move on to the third question. 100 over n, and n has to be positive integers. What does that mean? Okay, n has to be a positive integer. That makes sense. We can just assume that n is any positive numbers. But 110 over n. In order for this one to be a positive integer, that means n, you see the denominator n has to be a factor of 110, you see? Otherwise, it cannot divide evenly, and then it's going to give you decimal values. Then this cannot be an integer. So, as you can tell, what has to happen is, then what are the factors of 110? Or how many factors does 110 have? Let's just think about it. 110, in fact, is equal to, you can see that 2 times 5 times 11. That's what 110 is equal to. The number of factors that which we discussed then will be 2 to the first power, so we end up getting 2. 5 to the first power, that means we're going to add 1 to it, so we end up getting 2. And 11 to the first power, so adding 1, we end up getting 2. So 2 times 2 times 2, total, there are 8 such numbers that will satisfy this condition. Just for your information, those numbers would have been 1 and 110, 2 and 55, 3, no, 4, no, 5, and 11, no, 5 and 22. Next one is 10 and 11. So we have these 8 numbers. Alright, let's look at number 4. explain why it is good to have a degree measures of one complete revolution to be 360 instead of 500 or 300 as an example. In fact, 360 is a good number because, as we discussed in class also, you see 360 is a number that has very high number of factors. For example, let's see how many factors does 360 have. Since the number is rather big, let's break it down. Then we have 36 and 10. This becomes 2 and 5, and this becomes 6 and 6, which ends up being 2, 3, and here 2, 3. In other words, 360 becomes 1, 2, 3, 2 to the third power times 3 squared times 5. That's exactly what we end up getting. So that means number of factors for 360 becomes 3 plus 1 becomes 4 times 2 plus 1 becomes 3 and 1 plus 1 becomes 2. So that's we get 24. 360 has 24 factors. On the other hand, how about 500? 500, when you factorize 500, then we end up getting 2 squared from each 0 and 5 to the third power from each 0 and then one more. In other words, number of factors in this case we'll end up getting 2 plus 1 becomes 3, 3 plus 1 becomes 4. So in fact, you will realize that this one only has 12 factors, when in fact 360 has more factors even though the number is smaller. So as you can tell, that is the reason why 360 is a good number for one complete revolution than 500 or 300 or many other numbers for that matter. Alright, thank you, and I'll see you later. Have a nice day.